What if I gave you a graph like that and I said, draw this, okay? Now think about it. If I'm going to draw something, and if I'm going to draw a graph, what features am I looking for?
The x-intercepts.
Good.
The y-intercepts.
Absolutely. So I want to know where this is in relation to each of the axes. So I'm looking for the x-intercepts and the y-intercepts. I think they are the most important features of the graph at this stage. Okay? We are going to look at vertex and where the turning point is in just a second. But are you all happy? This is a type of x squared graph. So what does the x squared graph look like?
X squared graph. It will like,
Yeah. Or it could also be like that. Are you happy? Can anybody remember the name of this graph? Perfect. So we know it's a parabola. Parabola. Okay, good. Now, how do we know which way up the graph is facing?
If it's x is negative or positive, x squared.
The x squared, right? Because you remember when I gave you this at the very start, you told me that this was a reflection in the x-axis. In other words, you've taken y equals x squared, which we know looks like this. We looked at that on Tuesday, okay? And then we said, okay, to get negative x squared, you just reflect it in the x-axis. So it's that way up, okay? And that is true for all quadratics. If you see a negative in front of the x squared term, doesn't matter how many terms you have in your equation, you know immediately which way up it is, okay? Just think, if it's positive, you're happy, okay? If it's negative, you're sad, okay? Happy face and sad face. Make sense? Good. Okay, so which way up is this one in this case? Happy face or sad face?
Happy face.
It's a happy face, right? Because it's a positive x squared, all right? So we know immediately we're going to have a graph that looks like this, okay? Now all we need to do is work out where our intercepts are. In other words, where are we going to position our axes, okay? I'm going to start with this one. How could we work out where the y-intercept is of any graph? Not just a quadratic, any graph. How do we work out where the y-intercepts are?
I think it's the last number, the number without an x.
It is absolutely. So if you think about your y equals mx plus c, like we were looking at before, okay, it was the plus c that was the y-intercept, right? But more generally, how do we know that the last number is always the y-intercept?
is a constant.
It is a constant, but my question is, why do we know that that constant is always the y-intercept? Okay, so what we're looking for, the y-intercept, the y-intercept is the point which the graph crosses the y-axis, okay? Now, what is the equation of the y-axis?
X equals 0. Oh, yeah, right. So you replace x with 0.
Absolutely. So to find the y-intercepts, we always set x to be 0. And that's the reason why. If I gave you something like 3x plus 2, you would tell me, because we looked at it last week, that is the y-intercept. But if we set x to be 0, are you happy? We get 3 times 0, that disappears. Yeah? So the y-intercept has to be the thing without the x in, has to be the constant term. Does that make sense to everyone? Yeah? So in this case, where would the y-intercept be of this graph? Y equals x squared plus 4x. It would be 0, right? Because if we put 0 in here, we get 0 squared plus 4 times 0, that's still 0, okay? So in this case, the y-intercept is at 0, okay? So in other words, we know that the y-intercept is at 0. So when we put our y-axis in, it's going to cross the axis at 0, okay? Good. I'll write that in brackets in this case. What do you think we're going to do for the x-intercepts?
Where the y is equal.
It makes sense, right? Because if you think about it, we're looking at where it crosses the x-axis. The equation of the x-axis is y equals 0, okay? So we're going to set y equals 0. You notice that? So y-intercepts, set x to be 0. X-intercepts, set y to be 0. All good? Excellent. So let's do that. Let's set y to be 0. So I'll do the x-intercepts down here. Okay, so to find the x-intercepts, we're going to set this to be 0. So we're going to get 0 equals x squared plus 4x. Is everybody happy with how I got that? Yeah, I've literally just replaced y to be 0. okay? Now, how am I going to solve this? In fact, let me rewrite it. So I'm going to write it as x squared plus 4x equals 0. I think that looks a little bit more familiar, okay? I've literally just swapped the sides over, okay? How can I solve something like that? Yeah, exactly. So you're noticing that there is an x common to both terms. What's a better word, or what's one word that sums up taking x out? What's a better word for that? Factorize, yeah? So I'm asking you to factorize this. Okay, so if I factorize this, I take an x out because it's common to both terms. What's going to go inside my brackets? Yeah, 4 plus x or x plus 4. Let's keep it consistent with what's going on up there. Does that make sense to everyone? Okay. Now here's my question. Where am I going to go with this? How is this useful for me? How is this helpful?
You come up with two answers, correct?
How?
You have two factors, and the product is 0, so one of them has to be 0, or both.
Absolutely right. Yeah, did you catch that? So basically, if I said 3 times something equals 0, what has that number got to be? It's got to be 0. That's the only way I can get 0 from multiplying two numbers together. Yeah, exactly. And if I keep going, would you be happy? Something times 5 gives me 0. What's that number got to be? It's got to be 0, right? So the idea is that if I'm multiplying two numbers together and the result is 0, at least one of them has to be 0. Okay? So let's consider that. So I've got x times x plus 4. You happy? Here are my two factors. I've got something times something. And product, times them together, it makes 0. Yeah? So either this thing has to be 0. I don't know which one is 0, so either this one has to be 0. So the x has to be 0. Or this thing has to be 0. So x plus 4 has to be 0. Does that make sense to everyone? Because this is really important. Yeah, so that's the answer. But does this make sense to everyone? Yeah? Because I'm basically saying I'm multiplying two things together, it makes 0. Either that one's equal to 0, or that one's equal to 0. Okay? You notice the word or there? Really important because we don't know which one it is. Okay? So when you're writing this, you need to write down or. Okay? So, okay, if x equals 0, then that's one solution. If x plus 4 equals 0, then what has x got to be equal to? Do you see that? I take away 4 from both sides. Is that clear? Good. So here actually are my two x-intercepts. I have x equals 0. Let me try and write them here. X equals 0 or x equals negative 4. Okay. So now it's just a case of I am trying to put these axes in the correct place such that the graph, the parabola, goes through the points x equals 0 and x equals negative 4. That's where it cuts through the x-axis. So let me draw that in. Okay, so this point over here and this point over here are the two x-intercepts. So what's that point got to be? So negative 4 or 0? What's this one got to be?
0? No, that's negative 4.
It's got to be negative 4, right? Because negative 4 has got to be to the left of 0. Think about it on the number line, okay? Which means that that one has to be 0, okay? And I said that my y-intercept was at 0 as well, okay? Which means that it's got to cut through this point here. Does that make sense to everyone? Yeah?